Okay, so today and tomorrow we're going to talk about graphing the other trig function. So tangent, cotangent, secant, and cosecant. Because all of these and somewhere on the unit circle have a place where they would be undefined, because you can't divide by 0, and every time you're doing this you're flipping a point, because that's what cosecant and secant are. You're flipping your x, you're flipping your y. And then cotangent and tangent, where you're taking y divided by x and x divided by y, so there's a chance you could have 0 in the denominator. That would give you an undefined answer, which means if we're going to graph these, we're going to have asymptotes. Excuse me. So they're going to be lines that the graph approaches, but it never crosses. Okay? So today I'll do a couple problems on tangent and cotangent on the video, and then tomorrow we'll talk about secant and cosecant. Okay? Tangent and cotangent, instead of their period being 2 pi, like cosine and sine, and even secant and cosecant will have a period of 2 pi. Tangent and cotangent's normal period is pi. So to find the period, you're going to take pi divided by b. Remember, b is the number that's in front of x. Their asymptotes, if it's tangent, their normal asymptotes are at the pi over 2's. So pi over 2, 3 pi over 2, 5 pi over 2, etc. Okay? If it's cotangent, they're at 0, pi, 2 pi, 3 pi. They're all, so basically these are all at all the y-axis points at top and bottom, and these are at your x-axis. Okay? So to find your starting asymptotes, you're going to take whatever the x part is, or if there's a parentheses that has something subtracted. For tangent, you're going to set it equal to negative pi over 2 and pi over 2. For cotangent, you're going to set it equal to 0 and equal to pi. Okay? Then secant and cosecant have the same ones, except for their period is different. They're like cosine and sine, where their period is 2 pi. So how do I remember which ones are pi over 2 and which ones are 3 pi over 2? How I remember it is cotangent and cosecant both have 0. So I remember, I just say co, 0. So co, both have 0 as my asymptote. Okay? Alright, so we're going to do an example of tangent. And just like we did with sine and cosine, we're going to sketch 2 periods. Okay, so the very first thing I want to do on these, there's no amplitude, because on cotangent and tangent, their graphs look kind of like cubics. Like this one is like a regular tangent, this one would be like a regular cotangent. So they don't really have amplitudes because they go on forever in the vertical way. So when you're graphing, just do like one above and one below, just to make sure you have enough space. So if you're thinking about with sine and cosine, that would be like the number in front. So my number in front is 1. So when I do my graph, I'm going to go like to 2 and negative 2. Okay? Alright, so to find my period, I'm going to take pi, we're doing tangent, so pi divided by the number in front of x. Well, my number in front of x is a half. So I'm going to take pi divided by a half, which would be like multiplying by the reciprocal. So pi times 2, which would be 2 pi. Okay. Then I need to figure out where do my asymptotes start. So I'm going to take the x part. Okay, so this is a tangent one. So you're going to have it set equal to pi over 2, negative pi over 2 and pi over 2 is what I've written down. So we're going to set this equal to negative pi over 2, and we're going to set it equal to pi over 2. Okay, and we're going to solve for x. So this is like, if they both have 2's in the bottom, if those cancel out, so x equals negative pi. These both have 2's, they cancel out. X equals pi. The distance between these two numbers should be the length of your period. Okay, well between negative pi and pi, that's 2 pi. That's the length of my period, so I know I'm okay. Alright, so when I go to graph, so I'm at negative pi and pi. And I know I'm going to go up to at least 2. Okay, so if I want to do 2 periods, if I measure out this length, the length of the period is 2 pi, so to find my next ending point, if I take pi plus 2 pi, I'm ending at 3 pi. Okay, just like with sine and cosine, to figure out what you're counting by, you take your period and divide by 4, so I'm counting by pi over 2. Okay, every period still gets divided into 4s. So my asymptotes I have here, here, and here. And every period gets divided into 4s, so we're going to divide it into 4s. And I know I'm counting by pi over 2. So if I was negative pi, add pi over 2, I'm at negative pi over 2. Add pi over 2 again, I'm at 0. Add pi over 2, I'm at pi over 2. Then I have 2 pi over 2, which is pi. Add pi over 2 again, I'm at 3 pi over 2. And again, I'm at 2 pi, because that's 4 pi over 2, and then I'm at 5 pi over 2. Okay, then I just plug them in and solve. So if I put in every period, the transition point is going to be at 0, or if it's shifted up and down, wherever that point is. Okay, I'm going to plug it in to prove it, but this is going to be here. Whatever you find for the first period, just like with sine and cosine, it's reciprocal for the second period. It's the exact same thing. Okay, so if I take negative pi over 2, if I plug this in, I would have negative pi over 2 divided by 2, which would be negative pi over 2, you divide by, same thing as multiplied by the fraction, by the reciprocal. So I'm really finding the tangent of negative pi over 4. Okay, if I'm looking at thinking about my graph, negative pi over 4 means I go down. So negative, that puts me in quadrant 4. In quadrant 4, I have my point at negative pi over 4 is square root of 2 over 2, negative square root of 2 over 2. And tangent is y divided by x. So if I divide those, I get negative 1. So the tangent of that would be negative 1. Multiply by the 1 in front, I'm at negative 1. Okay, if I put in 0, 0 divided by 2 is 0, so I want the tangent of 0, while the point 0, my point is 1, 0. Then I take y divided by x, so 0 divided by 1 is 0. Then if I do pi over 2, pi over 2 divided by 2, well that's times a half, so that would be pi over 4. The point at pi over 4 is square root of 2 over 2, square root of 2 over 2. If I divide those, I get 1. And then 1 times 1 is 1. These look like cubic graphs. And whatever happens in the first period repeats in the second period. Okay, I'm going to make another graph. I'll have a couple more examples of tangent and cotangent. I'm going to go ahead and stop this one.